Welcome back to another explainer. If you are currently staring down a massive mountain of raw data for your statistical analysis, or maybe you're just cramming for an upcoming exam, well, you're in exactly the right place. Today we're tackling one giant problem: organizing the chaos. Imagine walking into this colossal warehouse where millions of random, completely unlabeled items are just piled all the way up to the ceiling. That is literally what raw data looks like before we touch it. It's overwhelming, it's messy, and honestly, it's completely useless in that state. So in this revision session, we're going to build a mental concept map to tame all that data chaos, transforming it from a messy pile into a sharply structured, incredibly powerful tool.
Here's the roadmap for our structured revision today. First, taming the data chaos. 2, why we actually classify data. 3, classification by attributes. 4, classification by variables. And finally, number 5, the ultimate revision summary. Let's just get right into it.
Section 1. Taming the data chaos, organizing the mess. So before we can analyze absolutely anything, we really need to anchor our concept map and establish exactly what classification actually means in the world of statistics.
Here is your core bulleted definition for your notes. Classification of data means arranging a mass of data into different classes or groups on the basis of their similarities and resemblances. You can really think of this process kind of like the sorting hat in a fantasy novel, right? All the similar items of data are identified and put into one distinct class, and then all the dissimilar items are separated out and tossed into completely different classes based on their specific characteristics. It's the absolute foundational act of creating order out of chaos.
Moving on to Section 2. Why we classify data and our core objectives. Okay, let's dive into this. We know what it is now. But really, why do we put in the agonizing hours to do all this sorting? Why even bother?
Well, if you're jotting down notes for your revision, this is the punchy, easy-to-memorize checklist that you absolutely need. We've got 5 core objectives here. First up, to simplify data. It takes this giant, unwieldy mass of information and shrinks it into a concise, simple form. Second, to facilitate comparison. By grouping those similarities together, we can actually see the clear differences and draw immediate comparisons. Third, to highlight significant features. Classification literally points out the most important aspects at a single glance, which lets us draw meaningful conclusions super fast. Fourth, it provides a basis for tabulation. Actually, scratch that. It's more like you literally cannot tabulate or run any further statistical analysis until this specific groundwork is firmly laid. And fifth, to reveal patterns. It exposes those underlying characteristics that were completely hidden in that raw, chaotic pile.
Section 3. Classification by attributes. Dealing with qualitative data, let's see how this builds out the rest of our understanding. We've covered the what and the why, so now we're exploring the how branch of our concept map, focusing first on qualitative methods. Now, this is exactly how we handle data when numbers completely fail us. Classification according to attributes is used entirely for qualitative characteristics. Things we cannot physically count. You obviously can't put a tape measure around a person's religion or their intelligence, right? So instead, we draw natural lines of demarcation based on the presence, the absence, or the differing qualities of an attribute. We are effectively dropping people or items into distinct qualitative buckets.
Within this qualitative method, we actually have a really simple comparison to memorize for your exams. First is simple classification. This is when your data is classified by only one single attribute. Think of taking a room full of students and sorting them solely by sex, male and female. Just one clean dividing line. But then on the flip side, we have manifold classification. This is where you layer those attributes and classify your data based on more than one characteristic at the exact same time. So instead of just sorting those students by sex, you sort them by sex and marital status simultaneously. You're overlapping the attributes to create these highly specific, targeted groups. All right, Section 4. Classification by variables. Dealing with quantitative data. We are officially leaving the world of abstract qualities and moving to the things we actually can measure. So, the crucial point here is absolutely cementing this difference in your mind for your revision. On one side, we have what we just covered, right? Qualitative attributes, things that absolutely cannot be counted. But on the flip side, we have quantitative variables. These are the things that definitively can be counted. We're talking about exact wages, someone's age, physical height, or the marks you just got on a test. This contrast is literally the most vital distinction you need to remember when you're looking at any new data set. And that brings us to the formal definition. Classification according to variables is used for quantifiable characteristics that can be directly measured and expressed numerically. Unlike our attributes, we don't really have to look for the abstract presence or absence of equality here. We just look straight at the raw numbers. We measure the precise height, we record the exact wage. But there's an inherent challenge here. Because numbers can have absolutely infinite variation. I mean, think about measuring height down to the exact millimeter for 1,000 different people. We need a highly specific way to group these wildly fluctuating quantifiable variables together. Because if we don't, we're right back to the chaos.
So, to handle all of that infinite variation, we use the ultimate organizing tool, frequency distribution. When you've got a massive list of different test scores, for example, you don't just leave them in this messy, endless column. You organize that numerical data into specific classes, say scores between 80 and 90, and then you show the number of observations falling into each of those distinct numerical buckets. That resulting number of observations, that is your frequency.
Just think about the sheer power of that for a second. You can take thousands upon thousands of chaotic, raw data points, maybe the individual wages for every single worker in a sprawling city, and you can sort them perfectly into just 5 neat, easily readable frequency classes. You have basically taken the chaos, applied the variable classification, and created instant readable simplicity. It's a real game changer.
Which brings us to Section 5, the ultimate revision summary. Wrapping it all up. As we bring our concept map to a close today, it's super important to remember that successfully taming data chaos relies entirely on your grasp of these core tools. You really have to know your definitions, and you have to clearly distinguish when to use which method. To lock in everything we've just revised today, I want to leave you with this thought. Just look around the room you're in, or the people around you, right now. If you had to organize everything you see, how would you classify it? Are you looking at attributes that can only be grouped by qualitative differences, or are you looking at variables that you can directly measure and chart into a frequency distribution? Taming the chaos isn't just for passing statistics exams. It's literally how we understand the entire world around us. Thanks so much for joining me on this explainer. And hey, happy studying.